Recording for this meeting has begun.
So again, good afternoon, everybody, and welcome to another NICR webcast series with our presenter today, Dr. Dieter Valdez-Diaz from the University of Puerto Rico, Mayaguez. Let me tell you a little bit more about him before we get started. Dr. Valdez-Diaz is a professor of the Department of Engineering, Civil Engineering and Surveying at the University of Puerto Rico at Mayaguez. Dr. Valdez has obtained his PhD from the University of Texas at Austin, and his research interests include the application of operations, research tools, simulation, systems engineering, and system dynamics of the analysis, modeling, and control of transportation systems, driving simulations, and highway safety, information and traffic control strategies on urban networks, urban rail transportation system, information supply strategies during incident situations, intelligent transportation systems, optimal control, and fuzzy logistics and their applications to traffic control. So with that, I am going to hand the presentation over to Dr. Valdez. Are you there?
Yes. Thank you very much, Stephanie, and welcome to our webinar, everyone. I'll be presenting today the results of our NICR project titled The Implementation of OneBusAway in Mayaguez. This is the phase 1 of this project that will work with the behavior of the users as well in phase 2. Now, our research team at UPRM will work collaboratively on our projects. Our research team includes Professors Didier Valdez-Diaz, Alberto Figueroa Medina, Yvette Cruzado Vélez, and Carlos del Valle González, and the research assistants that participated in this project, Juan de Dios Martinez, Leslie Marrero Rodriguez, and Joshua Santiago Ibarra. I am Didier Valdez-Diaz, the PI of this project, and I will be presenting this webinar today on behalf of our research group. Our webinar starts with an introduction to our research problem and objectives, then the main tasks developed in this project, including the strategies to increase transit riderships and the detail of the implementation of OneBusAway in Mayaguez. That will lead us to our main results and future research. Well, as you may know, this is the mission for NICR, and our project fits perfectly into our NICR mission. This project is working on multimodal congestion reduction strategies and a real-world deployment that leverages advances in technology to improve transportation systems for all users. And in terms of our pillars, our project fits on NICR Pillar 3 that aims to incentivize transit in the face of innovative alternatives. We will present how we have been able to work towards implementing the aim of this important pillar in our project. Okay, well, as I was telling you before, the project in general, the two phases include influencing travel behavior via an open source platform. And I am presenting here today the phase 1 that deals with the implementation in Mayaguez of the open source platform OneBusAway. I want to acknowledge the support of Dr. Sean Barbeau and his research team at USF on this phase of the project. In the second phase, we will explore how to influence travelers' behavior and integrate this open source platform to improve transit operations. We will be using a new survey tool developed by USF and implemented USF and the University of Texas A&M and implemented in OneBusAway for the second phase. Okay. Now, let's talk now about phase one of our project. The objectives of this phase one was, the main objective was, of course, implementing OneBusAway. I'm going to call it OBA for short, in Mayaguez. However, in preparation for phase two and also for the general completeness of our project, we also studied the strategies to increase transit ridership, and I will touch a little bit on that topic as well. As an introduction to our topic, let me contextualize then our project in the current and future developments that we face in our cities and their transportation systems. In the future that is already here, actually, we will be working with transportation systems in smart cities with high mobility and connectivity. Multiple sensors and communications will make it easier to plan our trips and improve our travel experience. We are working towards this future. We will need to continue improving and promoting transit systems to make a better and more sustainable use of our transportation infrastructure and make that infrastructure available to all users through complete street projects. For our project, I would like to stress the point of mobility and connectivity. Bus services traveling on the transportation network with sensors that indicate their position all the time, and therefore users receiving that information on their own cell phones or electronic devices. But of course, not only that, all this means sensors, connectivity, and mobility for all transportation systems and all users. So we are looking at real-time information available for transit and other transportation modes as well. But of course, the field is rapidly evolving to electric, autonomous vehicles, and using big data and artificial intelligence developments to offer mobility services to all. Now, in terms of the strategies to increase the ridership, I was telling you that I will touch a little bit on this part as well. So let me talk briefly about these strategies. Several strategies have been developed over the years to increase the number of users in our transit system. Among them, we include here a demand-responsive transit, or DRT, placemaking, mobility as a service, and transit-oriented development. And of course, the real-time transit information. All these strategies are geared towards improving the transit system and also focusing on areas that are served by transit and to improve also the mobility of the users. Now, our project here focus on this part, which is improve rider information. And this strategy provides users with real-time information about the bus location and expected arrival times at bus stops, reducing waiting times, allowing better planning of the user's trips, and increasing ridership and rider satisfaction. So we're going to be talking about OneBusAway. This is the open source platform that we have been implemented here in Mayaguez through this project. But first, now let's focus on the Mayaguez transit system, some of the details of the transit system. And to start that, let me put Puerto Rico in context both geographically and in terms of congestion. As you can see on the map here, Puerto Rico is a Caribbean island located to the southeast of Florida, and the traffic congestion is an everyday problem that we face in our most populated areas. The data of the Urban Mobility Report prepared by the Texas A&M Transportation Institute indicates that our users in Puerto Rico experience high levels of congestion and millions of hours of delay with dire consequences in terms of annual loss in productivity and wasted fuel as well. Now, Mayaguez is located in the center of the western part of Puerto Rico that is highlighted with the red circle on this map. The San Juan metropolitan area that many of you may be more familiar with is located in the northeast quadrant with 78 municipalities, where many of them have their own transit system. There is a great potential to expand our project to other municipalities and increase ridership while addressing also congestion. Here you see a map of the Mayaguez area, and the Municipality of Mayaguez is highly urbanized on the western coastline. The main arterial is known as Highway PR2, where the bulk of the commercial activity takes place. And the inwardmost part of the municipality includes rural, mountainous, and residential areas. According to the U.S. Census Bureau, the estimated population in 2019 was around 75,000 people. Go here. Here you can see more details, a closer look of the Mayaguez and some images of the bus system, the main plaza at the city center, the main administration building of the University of Puerto Rico at Mayaguez, and the general view areas of the city and some of the streets. Now, there are two, in terms of the transit system, there are two bus systems that will be included in this project. The first one is operated by the university and is geared toward providing mobility to the university academic community. The second bus system, known as TIM, Integrated Transit of Mayaguez, for its acronym in Spanish, is operated by the Municipality of Mayaguez and serves the general community with urban and rural routes. Now, here you can see the routes that are operated by the UPRM Bus System. These routes are focused on providing transportation to the students of the university from common points of interest like students' residential areas and satellite parkings to the center of campus. Now, the municipality, the bus system for the municipality is divided actually into two subsystems, the urban subsystem and the rural subsystem. The urban roads operate by frequency and are organized and operated by the municipality. These routes are limited to the CBD and its neighboring areas, and the rural routes are organized by the municipality, but the operation is subcontracted to a private operator, as you can see here, Zonal Transit. It operates by schedule as presented on the table to the right and serves the outermost reaches of the municipality, providing services for the daily commute of its users. Here I'm presenting the terminal in the image in the upper left-hand corner, the terminal for the rural routes, and the other images present various types of bus stops for the TIM system. Now, images of the vehicles. for each one of the transit systems in Mayaguez. Starting from the left, left to right, we have a vintage bus used in the urban theme system and the minibuses used on the rural and the UPRM system. All vehicles have 25 seats. However, due to the COVID restrictions that we have at this moment, currently all vehicles have a limit of 5 passengers, which is due to this pandemic. Okay. Now, let me talk now about our project, or the implementation, the OneBusAway. We have established the baseline for Mayaguez, the transit system. So for this part, I'm going to start with a video that was developed by our research team as a dissemination of our project. Thank you. Well, as you can see, that video actually was developed for part of the project, as each one of the projects in our NICR site had to develop some strategy to talk to our students at the schools and to disseminate our project. So this is something that we did for that purpose, but I thought it was useful here just as an introduction also to our implementation. So our project aims at providing real-time passenger information to the users of the Mayaguez transit system by implementing OBA. And now I will present the details of the implementation process. Okay. First step was to gather the necessary data to create the General Transit Fit Specification files, the GTFS files. And the GTFS is a compressed zip file utilized for the distribution and transmission of information on the transit system. The GTFS is composed of 11 text files that store the characteristics data of the transit system, such as stop location, schedule information, route information, and operational information. Now, our team worked with USF and the OBA developers to gather information, but we also looked at the implementation in other places. So as you can see here, OBA, or a version of OBA, has been implemented in several cities in the US and also in other cities around the world. So the implementation of OBA in Tampa, for example, was part of the USF development, and we are now implementing here in Mayaguez. In terms of the methodology, well, I think this slide summarizes the main steps of our methodology. And the first task was to learn about the software, of course, familiarize with the software, with OBA and the literature review. And then in task 2, we had to take the necessary steps toward involving the administration of the university and the administration of the municipality in our project, and include GPS units and install GPS units on the buses and begin the tracking system process. Then on task 3, we incorporated the mapping of each route and the respective stops. And then we had the task 4 that was divided in 4.1 and 4.2. The first one was basically to test the implementation that the program was running. And once that was done, then we had the OneBusAway running on the application and the final coordination to make it available to the general public. Now, the first thing that we did was to study the basic architecture of the application, and this was a very important step. So this starts with the GPS, of course, and the dynamic GTFS, which collects the dynamic data that will be presented to the users, or that will be processed and then presented to the users. Afterwards, we connect the GPS units to the TrackR server and begin the tracking of the system. One third step was incorporating the characteristics of the routes using the static GTFS, and then transit clock uses GPS locations and GTFS to generate predictions from the transit routes, which are paired with GPS devices. These predictions are accessed through the API. Then, in addition to transit clock, also, in addition to that, transit clock also was used to test the GTFS shape files. And lastly, OneBusAway generates, it takes the data from transit clock and then makes it presentable to the users. So for the first step, we had to use bus location data through GPS, and we started by testing which kind of unit we would like to install in the vehicles. So the location could be tracked by using a GPS device or by using a tablet. So if you use a tablet, we needed also a charger and of course a mount, so all the equipment was connected. Now, in terms of the GPS devices, we tested various alternatives for GPS devices, and the main difference between the GPS devices was the connectivity, while it was on a rural area in particular, because the first system that we are testing, this OBA, is in the rural area. So some specific regions were found that the tablets consistently had a better reception than the GPS devices. So that was the tiebreaker, basically, to identify and to decide that the best performer was the tablet. Then we decided to go ahead and install tablets in the vehicles. Now, of course, tablets have advantages and disadvantages. So the main benefit of the tablet was the portability. A tablet could be quickly swapped between buses if necessary, and additionally the tablet is easy to set up and change if damaged, and also to run the programs or the apps that need to be run. You know, the GPS device could also be implemented, but then for the GPS devices we also have advantages and disadvantages. So the GPS device has the benefit that it is more cheaper than the tablet, and in some areas it does have a very good signal. So, but it wasn't as effective in the rural areas as we needed. So that was the main reason for why we decided at the end to use tablets for our implementation. Now, while using a tablet or a mobile device in order to connect to TRACAR, the TRACAR app is needed. And as seen on step 1, the TRACAR app shows that the device has been connected. Here on this slide, on the number 1. Now, and the location can be seen on the server status for a particular connected GPS unit. Then the third image shows TRACAR presenting the trajectory of a GPS through a route. Now, these coordinates and the GPS signal accuracy can be seen on the output given on step 4. This data will be stored on a cloud server or on a local server, depending on the decision that we have. And in our case, we're using a cloud server. So, a local server will have to be actively maintained, so the acquisition and maintenance cost will be high. And when using a cloud server, the scalability will be more effective and the runtime will be more efficient. In addition, a cloud server facilitates collaboration and data backups. In terms of the preparation of the GTFS static files, this was the first step to create the static GTFS, to collect the data needed for each of the text files inside the compressed zip file. The GTFS best practices were the reference that we use to follow in each one of the steps that we follow to create these GTFS files. Now, we understand that the most important files to obtain the results, good results for the implementation of the OneBusAway are the shapes text file, the stops, and the stop times. However, all the other files are needed and are very important as well. Now, in terms of the geolocation with the GeoTracker, the information in the shapes.txt and stops.txt were gathered using a smartphone application, a GeoTracker. That allowed the research team to trace the routes and stops geolocation data in KLM format that was later edited using GIS software and exported to text format to then place it in the GTFS zip folder. This looks like a runaround, but it was really a good strategy for us since we didn't have the geolocation of the routes previously to work with them. So this was the solution that we found, and it worked perfectly, at least at the beginning. Let me show you a little bit of the problems that we had in another slide. But anyway, the final results of from the route geolocation task. The final results are presented here, and you can see all the routes and stops and the respective names and description and all the information needed for the GTFS files. Also, the schedule on the itinerary of all the routes was estimated using data provided by the private administrator, operator of the system, and the scheduled exit time from the terminal. And the itinerary data was estimated because the buses share the right-of-way with the rest of the traffic. It's a mixed traffic, so they are subject to random variations on arrival times as well, so we had to work around that situation. And now, what I was telling you before, we got some errors on our GTFS. Even following the GTFS best practices, and after verifying the GTFS files using a transit feed with the updated version of transit feed, the software verified that the GTFS files and signals were fine, you know. So we did this step first, and then used those GTFS files once corrected to input as an input to Tracar and the other files, the other programs. Sorry, but what happened is that there was still some errors that we encounter in this process. One such example are the straight lines jumping between stops that seem out of place. And it was an error created in the loop creation of the GTFS files. This error we found that was produced when the points that make up the lines of the route are not consecutive or in consecutive order. So this was an error that was present but was not detected by transit feed. Therefore, it's not an error of the GTFS files per se, but it created an error in the prediction of the arrival times when the information was past the transit clock. So, to correct this error, the point that formed the route lines must be a consecutive order and the same direction of the bus. Therefore, what was finally done was to divide the route in two directions, even though the buses were traveling along one road only. Well, it was as if we have the geolocation for the center line of one lane in one direction, and then coming back in the other direction, the geolocation of the other lane. So there were parallel lines, but each one individually identified for each one of the directions of for the route. Okay, transmission data to transit clock. This image shows the computing process to transit clock to make the arrival prediction of the buses. And the terminal output you see as a reference to the API request that can be made to transit clock. The API offers a variety of visualizations for the prediction data and map trajectories. Now, I will present the results of the implementation. Yeah. So once everything was running fine, then we started with the demonstration of the operation, and the image on the far left references a route visualized using transit clock, the route has an active vehicle, and then the other 3 images correspond to the OneBusAway instance inside Mayaguez transit system. The second image shows the specification of a bus stop and the predictions for that particular stop. The following images show an overview of the stops and a visualization of a route inside the application. These are the general instructions that we started preparing a manual for the general public to work with the application. So these are the general instructions at the beginning to access the application and the selection of the region of interest. So now please present the next video. Choose the region. In this case, this is an iPhone NICR system. And then it demonstrates how it opens up. And you can zoom in to look for the stops. So this video demonstrates the active Mayaguez beta that is currently available. Okay. Oh, oops, what happened? Oh, I'm sorry. I think that the presentation jumped to a previous slide. I'm sorry about that. Thank you very much. Okay. Now, after that, we started running some simulations as well, using the OneBusAway with different groups of students at the university and testing it with actual users on the field. So the first thing we did was test the predictions, and the data was taken from the transit clock server. So once the GPS devices were installed in the buses, we started collecting observed arrival times, compared to the predicted arrival times that the transit clock was generated. And this is what we found in these tests. Well, we performed a two-sample t-test, and several samples were taken to perform this test between the observed arrival times and the predicted arrival times. And in this case, for this sample, there was no statistical evidence indicated that the mean difference between the observed and predicted data was equal to zero. Therefore, we had some cases that this kind of result was obtained, and in other cases, like for example for this sample, we have statistical evidence that the means, the difference between the means was equal to zero, which means that the observed arrival times and predicted arrival times were statistically equal. Well, to go from the previous slide to this slide, we had to also adjust sometimes in our GTFS files. So basically, the predictions were at the end, the predictions are more accurate than what we initially had in place. And we haven't started yet with the whole community, for all the users. We are in the process of doing that. So we are still testing, and but we know that we expect benefits for the users, providing information in real time to increase the satisfaction and to increase ridership, enhance the efficiency and reliability of the system. This system it will be the first one in this area to have this kind of information in real time. So definitely it will reduce the waiting times and the perception of waiting time. And we will be using this tool for our future research, which will be working with the survey inside of OneBusAway to work with the behavior of the users, and now not only for users that not only take the bus right now, but we also take other modes of transportation, and but live in the vicinity or in the area of influence of this type of system. So we can collect data from all of them and process that data and inform you in a future webinar about the results of our phase 2. So thank you very much. You have here the research team contact information, and I'm here to answer questions if you have some. Thank you very much.
Thank you so much. So what I'm going to do now is just remind everybody, in the bottom right-hand corner of your screen, you do have the opportunity to submit some questions, and we're going to get to the Q&A part. So again, locate that Q&A box in the bottom right-hand corner of your screen. Type in any questions and or comments you may have, and we'll get those read aloud and get them answered. So let's start with the first question. It says, if someone was to set up OneBusAway in a new city, what is the most important piece of advice you could give them based on your experience?
Well, I think that pay attention from the beginning to the GTFS files construction, because it is a very important piece of information. And for the static GTFS, if we wouldn't have separated the two directions of flow, we will continue having trouble with the predictions in intracar and so definitely that would be the most important piece of advice. In our case, I'd have to admit that in our case, we have kind of a unique type of routes, because as you were saying, we have only one terminal, and the buses exit that terminal according to certain schedule, and then go to the end of the line and then come back, but there is no additional terminals at the end of the line. So it's kind of a cycle, basically. So in this case, if you have a different type of arrangement where you have another terminal at the end, well, maybe the routes split, and the GTFS will work differently. But this part was one of the main parts where we had trouble, and we were looking at GTFS files from different applications in various cities, and surprisingly, we found that in many of those cases, there were also these kind of errors in the GTFS files, but they were using it. So what I can say in that case is that maybe the structure of the routes were different for them, and it was working for them. But for us, it didn't work until we finally improve that part. So I would say that will be the most important piece of advice.
Perfect. Okay, here's the next question. It says, is real-time information available in any third-party app?
No, we don't have real-time information available in third-party apps. That is something that if a third party is interested in using OBA, well, there is a process to use it. We have followed, and it has taken some time, to get used to it. But no, currently there is no access to that information to a third party.
Okay, thank you. Another question comes in and says, does the prediction time vary by time of day or day of week?
Excuse me, can you repeat the question, please?
Sure. Do prediction times vary by time of day or day of week?
Prediction times. Well, what happened is that the prediction times depend on the information that we have in real time for the vehicles. So, of course, it will vary all the time, because depending on... okay, now let me focus on the question. Yes, the prediction times will be part of their real-time application. However, the prediction times, the scheduled time for each one of the stops would not vary. Those will be the same because this system works by schedule. What varies is the real-time part of it. The real-time prediction would vary according to whatever is happening along the road. If there is congestion, for example, and the bus is stopped, then the prediction for when that bus will arrive to a certain stop will be different from the scheduled arrival time.
Okay, the next question says, did you try or had you considered using bus stop sensors to improve accuracy?
No, we have not. I think that's a good idea, maybe a good improvement for the future for OBA. But no, we haven't tried that part in this system.
Towards the end of the presentation, you spoke a little bit about phase 2. Can you talk specifically about what is going to be happening in phase 2 of this research project?
Certainly. On phase 2, we will use the information provided by the users of the system. So this is what we're doing right now. We are making the final testing process to make sure that everything runs the best that we can make it run, and providing the user manual for the new users of this particular piece of application, so they get familiarized with OBA. But we also are asking, and the new OneBusAway application asked the user if they would like to help us to improve the transportation system. So we can gather some data from them, and this is an option, of course. But we will use that option and ask ask people who are working using that application to use that option and allow us to gather information on their travel behavior. So we will use that information to know a little bit more about the characteristics of the travels of the trips for the population that lives in the area of influence of these routes. And with that, we will apply geographical information systems to make some correlations and identify opportunities for people who may not be using our system to provide them information about the system and and try to get them to use it, to improve transit ridership and keep on continuing taking cars or vehicles out of the street and putting some of that those trips into the transit system. And we can see with that we can see if that is something that is possible, is doable, and what kind of strategies do we need to generate in order to get that type of result.
Okay, then the next question says, what cloud server provider are you using for the tracker, the transit clock, and OneBusAway servers?
We're using DigitalOcean as our cloud server. This server provider is very useful because they are running backups and additional programs, so we can actually, well, we have one of the research assistants in our team has been working with this server, and every step of the way he was able to connect all the programs to this server, all the data, handle the data inside the server, and then the last piece of the process was to make sure that the data was secure. So, and that part took a little bit of additional work, but it was possible, and finally our system is in the beta version on the OVA site.
Okay, well, we have time for one more question. It says, any major difference or lessons learned in the iPhone versus Android platforms of OneBusAway beta versions that you can share with us?
Well, I understand that this is an open source platform. So for users of one type of technology, Android, or for users of iOS, it may have different features. But what I would say here is that the way the application looks in both systems is very, very different. It has different features in each one of them, but I'm certain that this is a part of the application of developing something where many different minds come to place, and that will be, I would say, it's not a concern, but if it is possible, it would be nice to have something that looks similar in both systems. Other than that, for example, the way the routes look in an Android phone are much better, have more capabilities than the capabilities that we have in an iPhone. But with what we have in an iPhone, we can do the basic operations that we need, and we can see the same things. A little bit more difficult maybe, but it's basically the way the things are presented in both systems.
Okay, we've reached the end of our time together. I know there are several questions that are still in the queue. What we're going to do is I will send them to Dr. Valdez at the end of today's presentation with your email address, so he can follow up with you via email. As I mentioned earlier, I'm going to open up the evaluation on your end. Please take a few moments to complete that evaluation as the feedback provides very important, as well as the entire NICR webcast series. We will be back on October 7th at 12 o'clock for the evaluating the accuracy of smartphone-based travel behavior data with two researchers, one researcher, Sean Turner from Texas A&M Transportation Research, and our colleague here at the Center for Urban Transportation Research, Dr. Sean Barbeau. Again, thank you so much for joining us today, and we'll see you in a couple weeks. Bye, everybody.